Okay, hey, let's do a real quick example. Not example, but homework problem is 476. I looked in the solutions in the manual, and they did not solve it how I would solve it. It was not obvious. I don't know why they picked the way they did it. It seems a lot more complicated than the way I like to do it. So I'm going to show you the way I like to do it. If you want to do it the way the manual does it, okay, knock yourself out. So here's what I have. Let's draw the free body diagram. So what am I going to do? Actually, let's look at that. The free body diagram. I'm going to take this body like this. I can go around here, and I'm going to cut through that little intersection like that. That's my free body diagram, right? So my body looks something like this. Um, there's a force here of 75 newtons. Here at B, since I cut through that, that's a pin. That thing is capable of two things. It's capable of a, didn't draw that very well, By and Bx, right? And then there's a tension here, since I cut through that line, and a tension here, and it has the same value. The tension is the same on both things. And that's my free body diagram. So I need it. So I have what? Three unknowns: bx, by, and t, right? So the first thing, let's take the sum of the moments. And where should we take the sum of the moments? So if I take it about here, so if I consider point A, I'm going to get rid of this t, but I'm going to have three unknowns, right? So that's not terribly helpful. But if I take the sum of the moments about B, all of a sudden I get rid of two of my unknowns, and that's equal to 0. So what do we have? We have the 75 times this distance right here, right, which is 0.16. Slide that. Oh, okay, that's the right place. And then it's going to be minus that tension right there, this tension here, times the same distance, which is 0.16, right? And it's going to be plus t, this t up here, times this distance from there to there, which is 0.12. 0.12 equals 0, right? So we're going to pull that to the other side, and therefore t times 0.16 minus 0.12 is equal to 75 times 0.16. So that gives you that t is equal to 300. There you go, boom. You know the tension in the cable. The tension in the cable is 300. Again, now it's the point out it's a frictionless cable and frictionless pulley and an inextensible cable. It just means that the tension that this thing is, the tension here is the same as the tension here. That's the beauty of cables. Okay, and then let's just do this. Sum of the forces in x equals 0. Well, we only have two x forces. We have this one and this one. So you can just look and see that bx is equal to t. You guys buy that? And so therefore that's equal to 300. Okay, and sum of the forces in y equals 0. Here we have one extra force, so we have minus 75 plus t plus by is equal to 0. So therefore by is equal to 75 minus t, which is equal to minus 225. Or in other words, by is 225 down. So the key to this, and to many of these problems, it's drawing a good free body diagram and then picking somewhere convenient to take the sum of the moments. If I would have taken the sum of the moments about this point right here, right? It's not marked, but it's at that point. You could do the problem. You could do the math. And actually here, y would cancel out because the y force passes through there. So that would be all good. But it just makes it harder than it needs to be. The beauty of taking the moments and the whole purpose of taking the sum of the moments is that you can find somewhere on that plot that you cancel out some or even a bunch of your unknowns. And it just makes it a lot easier to do the math. And that's how you do that problem.